Hi everybody. Today we're going to look at reading data files in Python, and specifically we're going to look at reading CSV files. Now I have two different files. One is a CSV file that contains 1,000 rows and is relatively small, and the second file is much larger with 10 million rows. Now if you look on the screen, we'll take a look at what these files contain. So I'll run the head command on the 1,000 rows file, and you'll see it's a basic CSV file that has the first row is a header, the name of each attribute, column A, column B, column C, and then every row after that contains the values of A1, B1, and so on for every row. Now we'll look at the tail of the larger file, the 10 million rows, and you'll see it has significantly more rows. Down here, this is actually row 10 million because it starts at 0. Now to look at the file size, the difference, you'll see that the 10 million row CSV file is over a gigabyte in size, which is significantly higher, or larger rather, than the 1,000 rows CSV file. Now, because of the size difference, we can take different strategies on how we want to load this data and process it, and we'll take a look at that in a minute. On the left-hand side, you'll see a Python module, and it's utilizing the CSV import statement. The CSV import statement, it comes standard in the Python library, and it's a module that allows you to interact with and read CSV files. Down here on line 11, you'll see that we have this with open statement. And what this is in Python is a context manager, which means that it automatically controls the opening and closing of files for you when you're finished reading or finished using the file. If you don't do this, then you'd have to manually close the file when you're finished using it. So using a context manager is just a convenient way to not forget to do that. So I suggest using the with open statement when you're reading files. In the next line here, we'll see the CSV.reader. And there's actually in this example, we have two readers. We have the CSV reader, and then down here on line 18, we have the CSV dict reader. And we'll talk about the difference in a minute, but the idea is that this returns a reference to a reader object that we can then iterate and get the values of every row, which you can see with this read rows helper function. Down on line 24, you can see what I mean by that. So for a row in reader, we can iterate this reader object and get the value of the rows. What I've done is set a trace on line 25, which will stop the execution there so that we can inspect what a row looks like. So when we run this file, well, you'll see we stop the execution on line 26. And if we want to print out the value of row, you can see with this CSV reader, the first row returned is the header row of the file. So we got column A, column B, column C. If we step through the execution to the next iteration, you can see that now we get the values of every row after that. And again, if we want to print out the next row, now we have A2. So you can see using the regular CSV reader, what happens is it quite literally reads every single row in the CSV file. So this might be an issue because obviously every row is associated, with a column, or every value in one of these rows corresponds to one of these values in the header row. So what Python provides is a dictionary reader that'll combine these values for us. So to show you what that looks like, on the left-hand side, we'll just change the reference from CSV reader to CSV dict reader, or dictionary reader. And when we run this, if we look at the value of row, you can see the difference here. Rather than a list of each value in the CSV, what we have now is a dictionary that has key value pairs of every column header and then the value in that row. So if we want to continue to the next row, you can see, we have column A, A1. Now in the next row, we have column A, A2. So I think that's a very convenient thing because Python is now automatically dealing with this for you. It might not be something that you necessarily want to do, but Python provides this out of the box for you if you like to have key value pairs in this way. Okay, so we have two different files, right? We have the 1,000 rows and the 10 million rows. Now, if you look on the left-hand side of the screen, you'll see that on line 26, we're appending the rows to a list. Now in a small file, this might not be a problem because having 1,000 rows stored in memory might not be an issue. But you could imagine on a large file like the 10 million rows, that's 1 gigabyte, that's going to eat a lot of memory as we're appending to this list. So to show you what I mean by this is we'll do the CSV dict reader again, but we'll pass the file path to the 10 million rows. And what we'll do is we'll use a program called htop, which will show us the memory usage as this script is running. So as we read this process, or as we run this script, you'll see that on the right-hand side under memory, you'll see that this is continuously growing, right? Because we're appending every row to that list, and that list is going to continue to grow to the length of that file. So it's effectively we're going to store a gigabyte in memory, and actually more because of all the Python references and a little bit of overhead that way. So you can see this machine has about 4 gigs of memory, but by running this script and loading those rows into that list, we're now exceeding that, and we're using a bit of swap space as well. So obviously this is an effective way to read large files. So what we're going to do is I'm just going to kill this process, and you'll see when we kill this process, we reduce the memory usage quite significantly. We're back down to about half a gig. So perhaps rather than reading and appending to this list every time, maybe there's a smarter way we could do this. And maybe that way might be to read the file in chunks. So we have a separate reader, which operates almost the same way. It's the exact same with the with open statement and instantiating the reader. But this time, perhaps we can check the length of that list using some sort of chunk size or chunking. And when we get to that size, we can just yield the value of that list. And what this yield statement does is it turns this function into an iterable. So on line 24, you can see that we can now iterate get chunks. So for chunk in get chunks. So every time we hit this yield statement, we're going to return X amount of number of rows. And then after we yield that, we're going to clear the value of rows. And what that does is reset that list back to 0 so that we're not continuously eating up the memory we have on our machine. So to show you what this looks like, we'll open up htop again, and we're going to run this chunk reader with a value of 25,000 rows. So we're going to run 25,000 at a time. So when we run this, you'll see on the left-hand side, we're going through each chunk of 25,000. But on the right-hand side, you'll see that the memory usage, it spikes a little bit because we're obviously loading 25,000 rows into memory. But you can see that it's not filling all the way up to 4 gigabytes like the other example had. So this could be one approach of how we could iteratively load a larger data set, without crashing the system, so to speak. So we'll open up the chunk reader again. This time I'll drop a trace just so we can see what each chunk is, or what value it contains. So you see again, we got the trace, we're stopped on line 26. And if we look at, let's say, the length of the chunk, you'll see that we're at 25,000. And this is a list, we'll check its type, or we'll get, let's say, the 10,000th element in that. And you can see it contains that dictionary pair that we saw in the other example. So I think this is a good overview of reading data files in Python. And I think we looked at a good approach of reading a fairly large file without running out of memory, which we looked at with htop. Thanks, guys.